Welcome students. Today in this video we are going to solve from question number 661 to 665, and all these questions are asked in our page electrical MCQs, and we are going to upload this video in our very own YouTube channel EEMCQs. So what is the first question? You have to find out the ratio of number of junctions to number of branches for this circuit. Okay. So what we will do, we will first mark the branches and the junctions. So see, this is a junction, this is another junction, okay. This is another junction, junction number 3, and this is junction number 4. So there are 4 junctions, and in between junction 1 and 2, this is one branch, this is one branch. So branch 1, branch 2. In between junction 1 and 3, this is a branch, so this is branch 3. In between junction 2 and 4, this is a branch, so this is branch 4. And in between junction 3 and 4, there are 2 branches. Okay, so number it 5 and 6. So there are 6 branches. So 4 by 6 will give us 2 by 3. So the ratio will be 2 by 3, and option C is the correct answer here. So now we will go for the second question, that is question number 662. In a purely capacitive circuit, the instantaneous power curve is a sinusoidal of dash the frequency of voltage and current. So we can assume that the voltage is given by V is equal to Vm sin omega t, which has been applied across the purely capacitive circuit or the capacitor. So what will be the instantaneous current? I will be equal to C dV dt, where C is the capacitance of the capacitor, which will lead to the expression Im cos omega t. Okay. Now the instantaneous power P is equal to V into I. So what we can write, Vm sin omega t into Im sin omega t. Okay. Now this can be written as Vm into Im by 2 into 2. Sorry, this is not sin omega t, this is cos omega t. 2 sin omega t into cos omega t. So this is nothing but Vm into Im by 2 into sin 2 omega t. As we know, 2 sin theta cos theta is equal to sin 2 theta. Okay, that means the instantaneous power is having a frequency twice than that of the frequency of voltage and the current for a purely capacitive circuit. So here option D is the correct answer. Okay, now we will go for the next question. What is the question? An ideal voltage source has dash source resistance. You know, ideal voltage source always has zero internal resistance, which is also called as the source resistance. Okay, so option D here will be the correct answer. And also in this context, an ideal current source has what amount of source resistance? Infinite. Okay, for ideal current source, the internal resistance will be infinite. So now we will go for the next question, that is question number 664. Okay, so what is the question? Determine the capacitance of a parallel plate capacitor composed of thin foil sheets 20 centimeters square for plates separated through a glass dielectric of 0.4 centimeter thick with relative permittivity of 6. So what we know? For a parallel plate capacitor, the capacitance C is given by epsilon 0 into epsilon R into A by D. Okay. So what is A? A is the area of the plates, and D is the distance between the plates. Okay. So here A is given to be as 20 centimeter square. Now what we know? We are doing the problems in SI units. So we have to convert it into SI. So this will be equal to 20 into 10 to the power minus 4 meter square. And the distance between the plates are given to be as D is equal to 0.4 centimeter, which is equal to 0.4 into 10 to the power minus 2 meter. And also the relative permittivity is given to be as epsilon R is equal to 6, and epsilon 0 is nothing but the absolute permittivity of free space, which is given by 8.854 into 10 to the power minus 12 farad per meter. Now putting all these value, we will get C is equal to 8.854 into 10 to the power minus 12 into 6 into 20 into 10 to the power minus 4 divided by 0.4 into 10 to the power minus 2. It will lead to, after calculation, we will get 26.562 microfarad. That means 26.562 into 10 to the power minus 12 farad. So option C here will be our correct answer. Now we will go for the last question, that is question number 665. Basically the question means the last question for today. So what is the question here? The question is, for the network shown in the figure, find the Thevenin's equivalent resistance as seen through the terminals A and B. That means we have to remove this 20 ohm resistance, that is our load resistance. We have to take this as load resistance and look back into this network from this point, okay, and find out what is the Thevenin's resistance. Now how to do that? We have to remove all the sources by their internal resistances. Now this is a voltage source, so we have to sort it, and this is a current source, so we have to open it. Okay, so how the circuit will look like? The circuit will be looking like this. Okay, after removal of all the sources by their internal resistances, the circuit will be looking like this. This is 5 ohm, this is 10 ohm, and this is 10 ohm. So the resistance between A and B, that is our RTH or the Thevenin equivalent resistance, will be given by 10 plus 5 in parallel with 10. That means 10 plus 5 into 10 divided by 5 plus 10, which will lead to 10 plus 50 by 15. That means this will be 10 plus 10 by 3, that will be equal to 30 plus 10 by 3, that means 40 by 3. That is the Thevenin equivalent resistance for the given circuit when we are looking back from the terminal AB. Okay, so option A will be here the correct answer. So I think all of the questions that has been discussed today are very much clear to you. If you have any kind of problem regarding the solutions, kindly comment in the comment section, and also if you like the video, kindly subscribe to my channel and also share it to your friends for their benefit. Thank you. Thanks for watching.